Okay, Edwin, you're not going to say anything? Fair enough. No worries. All right, here we go. So let's do the last one. Oh, we made it. Okay, I'm just going to do one. Okay, just going to do one. It's a lot. Ready, Alan? Excellent. Thank you, sir. All right, here we go. It says, find the intervals on which the function is both increasing and concave down. So first, just focus on increasing. Let's do that. And as Georgie said, you know how to do this. You've already done this. So if I'm trying to determine where the original function is increasing, what do I need to find? The first derivative, actually, Gael. The first derivative, right, small. All right, so the first derivative is 8x cubed minus 48x squared plus 72x. Find the critical points. Where is this going to be equal to 0 or undefined? You know right now. Don't have to worry about undefined. Let's take out the 8x. We have x cubed minus 6x squared plus 9. This is why I don't listen to Gaia. Just messing Gaia. I did. I blamed you. What? Right now I'm just doing increasing. So if I'm doing increasing or decreasing, I just need the first derivative. Okay? All right. Factors of 9 that add to negative 6. Ooh, they're the same, right? So I'm going to write it as squared. Do you have to write that as squared? No. You can write it twice. Totally fine. Okay, what are my critical points?
0 and 3.
Awesome. Okay, ready? Make the number line. Test points. Ooh, let me do this. Okay, what test points am I going to use? Negative 1, 1, and 4. Nice. Okay, remember I care about the sign of the first derivative. The sign of the first derivative. I know, I love this. So here we go. Ready? Yes, go ahead. When you're looking to see if your original function is increasing or decreasing, you only need to use the first derivative. The sign of the first derivative will tell you if your original function is increasing or decreasing, like where it is. Okay? If you're asking about where the original function is concave up or concave down, you've got to find the signs of the second derivative, what you just practiced. Okay? So we're going to do both here. Yes, I do.
What if one of your critical points is like 0 and 1?
Ooh, what's in between 0 and 1? Yes. It does matter. What he just said isn't true. In between doesn't matter.
It does.
And then what's going to happen? Like it doesn't matter. It's just the sign.
Yeah, I just care about the sign. I don't care about the number is. He's right. I just care about the SIGN sign. Okay, ready? Plug in negative 1. Plug in negative 1. Negative 1 minus 3 is a negative. But when you square it, it's a positive times a negative. That's a negative. Plug in 1. 1 minus 3. Negative. Square it though. Positive times positive 1. Positive. And then finally, plug in 4. That's all positive. Squared is positive. Times 4 is positive. So this is positive. So where is f of x increasing? F of x is increasing. Do I need to write 0 to 3 and 3 to infinity?
No.
I can write 0 to infinity. That's why I put this one here. So if it doesn't, no, that's why I did this, man. If it doesn't change, you don't need to stop and then start again. It's just 0 to infinity.
But if you plug that into the delta mark, would it count it wrong?
Like if I plugged in 0 to 3 and 3 to infinity? I don't know. Oh, I thought Renee was going to say. It counts it wrong? Okay, Gael says it counts it wrong. And you did both, and he said wrong? Okay, but it wasn't like a period issue like David had? Okay. Just want to make sure that we have that recorded forever, that David wasted 5 minutes of my life because of a period. Okay. Everybody good? How we're halfway done? Halfway done. The next part says, where is it concave down? So Giles' question, now I'm transitioning to talking about concavity. I need to look at the second derivative. So this is where I'm going to move over here and essentially repeat the process, but with the second derivative. So what is the derivative of 8x cubed?
4x squared.
And then this would be minus the
6x.
plus 72. Okay. Set it equal to 0. We can take out a 24. So x squared minus 4x plus 3. Now, do I care about that 24? No, not really. Factors of 3 that add to negative 4. They're both negative. Nice. David, you okay?
Yeah.
You know your leg is making noise, right? Okay. What are my critical points?
Positive 3 and 1.
All right. Make the number line. What's up, Georgie? If I made a mistake, please tell me. No. As long as you don't put parentheses. A lot of my students, not a lot, some of my students will put parentheses around that, making it seem like, bless you, like it's an ordered pair, 3, 1. No, they're both x values, so it's okay to write x equals 3, 1. But if you throw parentheses on there, then that's a problem. Okay? Okay. Test points? 0. 2. Anita, we narrowly avoided it. Right? We almost had your question, right? And then 4. Sine of the second derivative. I know I'm going fast, guys. I apologize. I'm trying to get this done so you can try one. Okay. 0 minus 3 is a negative. 0 minus 1 is a negative. A negative times a negative? Positive. Okay. Plug in 2. 2 minus 3? Negative. 2 minus 1? Positive. So that would be negative for the sign. Last one. 4 minus 3 is a positive. 4 minus 1 is a positive. That's positive. So I wanted concave down, right? So f of x is concave down on the interval 1 to 3. Right, because the negative here goes with this interval between 1 and 3. Yes. I'm not done. You guys think I'm done? I'm not done. But go ahead, guy. Oh, you want me to finish? Okay. No. Okay, so here's how to answer it, because I'm going to answer your question, Guile. The word in between is and. It doesn't say or. Right? It says and. So if it said or, go ahead. Write them both, put the U. Okay? This says and. All right? So on the one interval for increasing, let's just imagine, can you guys, I know you can't see at home when you're watching this, but if this is, well, let me do this. If this is 0 right in the middle of the room, that's negative infinity. That's to your left. That's positive infinity. You guys good? So from here, 0 all the way to infinity, I'm doing what? I'm increasing. Everybody good? Everyone saw that? Okay. Now, from here, 1 to 3, I'm doing what? My derivative is decreasing. I'm concave down. So how do I write the answer if I need it to have both things happening on this interval? Nice, Julia. Your brain figured it out. Can I try again? Let me try again.